Welcome to Understand the Math. In this video, we're going to learn about properties of logarithms. We'll start by looking at the three main properties, the product, quotient, and power rule, and we'll do some examples. We'll then look at some additional useful properties and apply everything we've learned by walking through some important example problems where we'll expand and combine logarithmic expressions. Let's get started. The product, quotient, and power rule are the three main properties of logarithms that you need to know. The product rule tells us that the logarithm of a product is just the sum of the logarithms of the individual factors. When you have a log of any base of m times n, you're just going to break this up to the log of m plus the log of n. Let's look at two examples so that we can see how this works. In our first example, we are going to expand log base 3 of 5x. You can think of the 5 as m and the x as n in our formula above. This gives us that the log base 3 of 5x is just the log base 3 of 5 plus the log base 3 of x. So we just broke it up into two pieces that we added together. Now we're going to do the opposite. We're given two logs and we want to combine them. Notice that they have the same base so that we can combine them. We can write down that log of 10 plus log of x is equal to the log of 10 and x multiplied together. So that's just the log of 10x. Notice in this last example that there was no base b written because we were working with a common log. Let's now look at the quotient rule. It's just like the product rule, except we're dividing m and n instead of multiplying them. The logarithm of a quotient is just the difference of the logarithms of the numerator and denominator. Instead of adding the two logs like we did with the product rule, we're now going to subtract them. Let's look at some examples. In our first example, we are going to expand log base 5 of x divided by 2. Because what's inside the log is a quotient, x divided by 2, when we expand it, we're going to subtract the two pieces. This becomes log base 5 of x minus log base 5 of 2. Let's now go the other way and let's combine two logs. They both have the same base, so we can combine them. They are subtracted, so when we combine them, we're going to have to divide the 15 and the 3. We have log 4 of 15 minus log 4 of 3. And this is going to be log 4 of 15 divided by 3, which we can simplify to 5. So our answer is just log 4 of 5. The third main rule that we're going to look at is called the power rule. The power rule tells us that the logarithm of a number or variable raised to an exponent, let's highlight our exponent in yellow, is just the exponent multiplied by the logarithm of the number or variable. So what happens is when we have that p sitting up in the exponent, we can bring it out in front and take it out of the exponent. Let's look at some examples so that we make sure we understand how this works. In our first example, we're going to expand log base 7 of x squared. Notice that we have a 2 in the exponent, and that's what we're going to bring out in front. Log base 7 of x squared is just 2 log base 7 of x. So we just brought the exponent out in front. In our second example, we are going to do just the opposite. We want to condense this expression. So what we want to do is to not have that constant 3 out in front. We can say then, using our power rule, that 3 log of x is equal to log of x cubed. So our constant 3 that was in front is now up in our exponent. Before we go on to do some more examples, I want to go over briefly some other really useful logarithmic properties. I've created a table to make things easier and listed the properties for a log with base b in green, the common log with base 10 in blue, and then the natural log with base e in pink. A logarithm of 1 is always equal to 0, and then a logarithm of the base, such as log base b of b is 1, log base 10 of 10 is 1, and then the natural log of e is equal to 1. Those properties are really important and may be worth memorizing. Lastly, there are two inverse properties that we need to look at. The first inverse property tells us that the log of the base raised to the power x is just equal to x. That just comes from the power rule where we can pull the x out in front, and then the fact that log base b of b is equal to 1. And then the second inverse property is the base raised to the log of that base of x is just x. I think seeing these properties in terms of the common log and the natural log just makes it easier to understand. Let's now look at some example problems that I think you'll see quite a bit in math courses that you might take in the future. In the first two examples, what we're going to do is use the properties of logarithms to expand the expression. Let's look at our first one. We have the log of a quotient, so we're going to start by breaking this log up into two pieces that we're going to subtract. This is going to be equal to the log of 3x squared minus the log of x plus 1 to the 8th. Now what we're going to do is look at our first log and split it up into two pieces because we have a 3 multiplied by x squared. This becomes log of 3 plus log of x squared minus log of x plus 1 to the 8th. Now that everything is split apart, we can take our exponents and pull them out in front. This becomes log of 3 plus 2 log of x minus 8 log of x plus 1. And that's our final answer. Before we go on, I want to talk a little bit about log of x plus 1. It feels like we should be able to break that up, but we actually can't. Log of x plus 1 is not equal to log of x plus log of 1. The only way we can break up a log is if the two factors inside it are either multiplied or divided, but not added or subtracted. Let's now look at our second example. We again have a quotient, so I'm going to begin by using the quotient rule and splitting it apart. This becomes natural log of x times the square root of y cubed plus 1 minus natural log of z to the 6th. Now let's look at that first log. It has two components in it, so we can split that apart, and we can write this as natural log of x plus natural log of the square root of y cubed plus 1 minus natural log z to the 6th. Now what we're going to do is we're going to pull out our exponents. We have a square root, which is the exponent 1/2, and then we have an exponent of 6. So let's go ahead and let's pull both of those out. This becomes natural log x plus 1/2 natural log y cubed plus 1, and then lastly, minus 6 natural log of z. There's nothing else that we can simplify, so I'm going to highlight this because this is our final answer. Let's now look at our second set of examples. In these examples, we are again going to use the properties of logarithms, but now we are going to combine the expressions. Let's look at our first example. The first thing that we want to do when we combine these expressions is take our constants, the 4 and the 3, and put them up into the exponent. So then we can combine the logs. We'll write this as log base 5 of x to the 4th, just pulling that 4 up into the exponent, minus log base 5 of 2 minus x quantity cubed. Now we can combine the logs. Notice that they are subtracted. So when we combine them, we're going to have a numerator and a denominator. We can write this as log base 5 of our numerator, which is going to be x to the 4th, and then our denominator, which is 2 minus x quantity cubed. And that's our final answer. The key to doing this type of problem is to start by putting the constant in the exponent. Let's look at our second example. I included this one because I wanted you to see how to combine logarithms when you have 3 pieces. We're going to start just like we did with the previous example by putting the constant, let me highlight these, we have a 3, a 2, and a 1/2 up into the exponent. This gives us natural log of 2 cubed plus natural log x squared minus natural log x plus 4 to the 1/2. In a minute, we'll make that a square root. Now we can go ahead and combine them. Whenever we have a plus, we're going to multiply, and when we have a minus, we're going to divide. This is going to be equal to natural log. We'll put a big parenthesis here because we're going to have a term on the bottom. On the top, we have a 2 cubed times x squared. And then on the bottom, we're going to have x plus 4 to the 1/2, and I'm just going to write that as the square root of x plus 4. Now we can clean this up by writing the 2 cubed as 8. This becomes natural log of 8x squared, all divided by the square root of x plus 4. And that's our final answer. And we're done. You now know all about the important properties of logarithms, and I hope that you now feel ready to do examples like this on your own. If this video has been helpful to you, please consider subscribing to my channel. Keep believing in yourself and have a great rest of your day.